This is Tahsin Mustafiz. I'm a student of Tripoli Department of Bangladesh University of Engineering and Technology. This is a project that we developed for our Control System 1 laboratory, Tripoli 402. And my other group mates are Shahriar Hassan, Saad Ahmed, Mahmudul Hassan, Shampriti Shaha and Smoth Jenny. So we call this project a car racing game. This project actually consists of two parts, a hardware part and a software part. We developed our hardware part using Arduino Mega. Here you can see it. This is Arduino Mega 2560 and there is a breadboard. I have connected a potentiometer here. This is a potentiometer of 5 kilo ohm. That means you can vary its resistance within the range 0 to 5 kilo. And there is this push button. I will explain it later. And there is a Bluetooth module which I will use for sending data from this Arduino to Android. Okay, first let me show you a demonstration of my project, then I'll explain it. Thank you. Okay, in this part I'm gonna show you the software part and how I'm controlling this software part using my Arduino and control system. Okay, as you can see, this here is a device that is capturing my hardware part, and you can see in this video in this part. Okay, and this Arduino is connected to my PC, as you can see here. Alright, here is my PC. Okay, so as I'm gonna show you, first let me open this. This game actually take almost 2 GB of my RAM, and my RAM is only 4 GB, so it kind of slow down my PC's performance. Okay, I've added a background sound in this game. Anyways, as you can see, this is the menu option of my game. Okay, just let me lower down my volume. Okay, here it is. This is start, instruction, requirements and about us. I'm gonna show you the start option later, but first let me show you the thing about us. Okay, I've just pressed on this and this is showing about us. Okay, just back again. Requirement, I'm pressing on this part. Okay, here it is, requirement. As you can see, it requires 2 GB of RAM, 2 GHz processor and at least 20 MB hard disk space. And I've already told you the hardware part, so I'm not gonna do that again. Okay, so this is the start option. Let me press it. Okay, this is the game. I have to rotate my potentiometer to control my car's direction and speed. Oh, it's finished already. Actually, for demonstration, I've designed this program in such a way that it will only run for 90 seconds from the beginning. As the 90 seconds were maybe over, so the game kind of stopped. Anyways, let me begin from the first. Okay, start. My video device cannot capture this video at very fast frame rate, so it's kind of lagging. Anyways, I'm rotating my potentiometer and you can see I am pressing this push button to accelerate. Okay, here it is. I'm pressing it again and this car is moving and I'm using this potentiometer. Okay, the thing is, when you will run this game, you will control to this car and move it just on the track, your score will increment, and when you are out of the track, your score will decrement. So here it is, you can see my score is 8 minus 84. We have added a voice control system into our game So a user can just execute a command from menu option by just saying the word. For example, if one says start, it will start the game. If one says instruction, it will show him instruction and whatever. But unfortunately it requires internet and I don't have internet connection right now. But I have recorded a video where I executed this voice command using internet connection. So I'm just gonna show you this. Okay, here it is. I'm gonna just say this. Okay. Start. Okay, as you can see, after 5 or 6 seconds it starts. Actually it has been executed. The thing is, that's the problem. It requires 5 or 6 seconds to convert your voice command into a string and execute your command. So we have designed two parts for our project. One part is for PC and another part is for Android. So here you can see, this is my tablet and this car racing BT, here it is. This is our designed Android app. Okay, I'm gonna just press it. Now as you can see that it's wanting to request access to your Bluetooth. Okay, I'm gonna just press allow. Now it's showing a list of available Bluetooth devices around. So HC05, this is the name of the Bluetooth module I'm using. Here it is. This is my Bluetooth module. Okay. And there is a background music playing here. Okay. I'm just lowering the voice. HC05. Okay, now. Okay. Now it's connected to my Bluetooth module and I'm controlling it. Yes, it is working nicely. I'm rotating it by pressing the rotating by potentiometer and I'm accelerating it by pressing push button. Now I'm releasing it. Yes. Okay. As you can see, its speed is okay. Now it's 0 because I have released the push button. So it's completely working fine. Here is the circuit diagram for our control system. As you can see here, there is this Arduino, there is this Bluetooth module, this is our potentiometer and some couple of registers here, and this is the potentiometer. The thing is, the potentiometer is connected with a resistor, is connected in series with this resistor, and there is this 5 volt applied at one point, and at another terminal it is connected to, yes, this terminal is connected to ground, and from one pin of potentiometer a wire is connected to analog read A0 pin. Okay, this is one analog read pin, and there is this push button. Sorry, actually it's the push button. This push button is connected in between a 5 volt and a A1 pin. There it is. Okay, the thing is, when the push button will be pressed, the 5 volt will appear at this A1 pin, and when it will be released, there will be no voltage at A1. So the thing is, we can actually vary the resistance of this potentiometer by rotating it. We can vary its resistance within the range 0 to 5 kilo ohm. So when the resistance is increased, the total current across it, the total current through it will be decreased, and so will be the voltage drop across this fixed resistance will be. So as if we can measure the voltage drop across this resistor from A0 pin, will show a decrease in voltage reading from this analog read pin. Again, if the resistance of this potentiometer is decreased, then the current will increase by the Ohm's law, and so will the voltage drop across this fixed resistor will increase because of the whole V is equals to IR rule. Anyways, so there will be an increase in voltage reading from A0 pin, and we can see this from this is actually my Arduino code. Okay, let me show you the serial monitor data. Okay, here it is. I'm rotating it, just ignore the ones. Okay, as you can see that, okay, there is this data is coming. The voltage across this voltage at A0 pin is being varied by rotating the potentiometer. Currently I'm rotating it. Okay, anyways, and the function of the push button is when the push button is pressed, there will be a voltage at A1 pin, and the Arduino will print a 1 at serial monitor, and when it is released there will be no voltage at this A1 pin and it will print a 0. But the thing is, when I'm thinking of sending this data from my serial monitor, using my serial monitor into processing, or when I'm sending this data to my Android set, I have to think of this delay thing. For example, okay, here there this line. As you can see, the delay function, the variable is 100. That means there will be 100 millisecond delay between each data sent. So if I have to send two data and I have to send them simultaneously, the thing is there will be a delay of 200 millisecond between each consecutive data, each potentiometer data and each push button data. So it will, as a result, there will be a lagging effect in our game playing. To avoid that, we have decided to send these two data combined. We are doing this by just multiplying the push button value, that is either 1 or 0, multiplying it by 1000 and adding it to our potentiometer voltage reading. So as you can see here, I'm gonna show you again. Okay, the push button is not pressed yet, it's just sending a 3-digit value, and actually as the push button is released, so the push button data is 0, and the data is 0 into 1000 plus 162 or 3, so the actual data is 162. But now I'm pressing the push button, so you can see that the 1 is appeared before the the potentiometer data. That means the push button is sending a 1. Actually there is a 1 is being printed at a serial monitor and it is being multiplied by 1000 and is being added to potentiometer data. So there is 1000 added to our data, and that's the reason it's printing a value above 1000. Now the push button is released. Okay, I'm sending this data both to serial monitor and to 10-11 pin, which I have declared as Bluetooth TX and RX pin for Bluetooth data transfer. Okay, so the Arduino part is over. Now let me explain the processing part. It's actually a huge code actually, so I'm just gonna tell you in short. The thing is, we have been using 3 libraries here, as you can see: processing.serial for importing the Arduino serial monitor data into processing, processing.video for background music, and for voice control we are using this STT getflourish.stt library. Okay, here it is, the code is here. Okay, first of all, in setup I have loaded all the images that I require, and I'm enabling voice control system by this segment. Okay, now let's move on. Okay, here it is. I have declared all the images that I will require. The thing is, every image requires a lot of data into RAM, and when the images are being loaded into using within the setup function of processing, it will take a lot of data of RAM. Okay, now draw function, it will execute it again and again. There are some conditions applied. For example, when the game will be started, there will appear a start screen, then it will delay for 3 seconds, and then it will show the menu option, and then depending on which menu option you have selected, it will show you another screen, another image before you, or just start the game if you press on just start option. Okay, this part is for just adjusting the location of the car. Okay, this part is for controlling the potentiometer. The data that has been being received from Arduino is actually a value greater than 1000 or less than 1000, and we have designed an algorithm to separate brake value, that actually push button value, and potentiometer value. Anyways, so the value is actually the potentiometer value. Okay, just move on. This part is actually for rotating the car, steering the car by just rotating the potentiometer. The data is being used in such a way that when you are rotating the potentiometer, the car will also rotate in the same direction. Okay, there is this brake value. Okay, the brake value, what does the brake value do? Actually, it increment the value of your speed. So when you are pressing this button, there will be this, it will add a 1000 to your potentiometer data, and the brake value actually separates this 1000, actually 1 or 0, it separates this 1 or 0 from the main data, and when the brake value is 0, the speed will be decreased until the speed becomes 0, or when it is pressed, the brake value will be 1 and the speed will tend to increase until it will reach a maximum speed value. Okay, there is this part for serial communication. There it is. Okay, there is this mouse pressed option. Okay, just moving on. Okay, there it is, the void command option. I have written this function for executing from voice command. So I have already told you that we are using a function, a library function STT, to convert your voice into string, and the string is being stored in this result. Is the string variable, and when it equals start, the game state, another variable declared, and the game state will be 2, and I've written the algorithm in such a way that when the game state will be 2, then the start option, actually the game will be started. And similarly, when the result will be equals to about us, that means when we'll say about us, then the game state will be equal to 3, that means about us image will pop up. And same goes for instruction and requirement. And there's this algorithm for executing commands when game state equals to 2, 3 or 4 or 5. Anyways, just moving on. So there it is, the void exposition function. It plays a very important role in our game. Its job is to determine whether to increase or decrease user's point or score. We have decided to take two options into account, and they are when the car is just moving on the track, then the score will be increased, will be incremented, and when it will be out of the track, the score will tend to decrease. And also when the speed will become 0, the score will also tend to decrease. So this algorithm is written here. The thing is, we are detecting the color of the car's position, the pixel position actually, and when it's not the right color, that means when the color is the color of track, that means you are on the track, and then your score will be incremented. But when the color is not the color of track, then that means you are out of the track, and then your score will be decremented. Okay, there it is. There is not much left right now. Okay, we are done already, and there you can see this void transfer function. It actually what can I say, just print the voice or print the string that you have commanded. Okay, so we are done with the PC part. Now we are moving into Android code. It's basically same except for the serial communication part. Actually we cannot connect with Android with serial communication like PC. We had to use Bluetooth, and actually it was a very tough job for us to find a library function that can use Android's Bluetooth, access Android's Bluetooth. So there it is. We have actually used a library function named KTI, which I have declared here. There is this bunch of library functions here, all under KTI. Anyways, and this import cassette function actually is being used for playing background music. Anyways, so it's basically the same except for this Bluetooth function. The Bluetooth actually requires some steps to be accessed. For example, you have to, when you are using Bluetooth in a smartphone, just first of all you have to access the permission to open the Bluetooth. So first of all you have to open the Bluetooth, then there will be a list of available devices around will be appeared on your screen. So you have to think of that. You have to make sure that the list will be appeared. So you have to write your code in this way, and after the list will appear, then you'll have to select one device from the list and you will be connected to that device. So this is basically done here. First of all, we have to enable option so that our app can access Bluetooth on any device. We have to put a tick mark in this Bluetooth and Bluetooth admin for accessing Bluetooth. Okay, as you can see, this bit start will request permission to start the Bluetooth in your device. Okay, just moving on. Okay, here it is. When this configuring, it's a boolean variable. When this configuring is true, it will print a list of the available device around, and then it will make this configuring function false. And when it is false, then the same process as PC that we have been talking about will be executed. Okay, there's nothing exceptional here, just pretty same code for PC and Android. Okay, there it is. As you can see, the controller potentiometer is pretty same. Just moving on. Okay, brake value, that means the push button data. Okay. Okay. So in this part we are converting. We are actually doing some stuff. The thing is that data is being received from Bluetooth module of Arduino as byte data. So first of all, we had to convert this byte data into string and then into integer. This function is doing the job. Okay, and then we are separating the potentiometer data and the push button data here. Okay, and there is this again exposition function. We'll do the same, and we are finished. So if you have any questions, just comment below. I'll try to answer, and thanks for watching.